Hi, everybody. This is Chapter 9, Geometric Figures, and I'm Alyssa Pierce, and let's go ahead and get started with the lesson today. All right. So for problem number 1, we're going to need to know a little bit more about parallel lines. So what are parallel lines? Let's show you a couple of examples that we have, and then let's have the Google definition of a parallel line. So Google says that parallel lines are two lines that are always the same distance apart and never touch. In order for two lines to be parallel, they must be drawn in the same plane, a perfectly flat surface like a wall or a sheet of paper. Any line that has the same slope as the original will never intersect with it. So here we just have a regular X and Y axis plane, and we have two parallel lines. No matter how far they travel, they're never going to touch. The same can be said for these two lines right here. So let's go ahead and jump into number 1. We're going to be given two parallel lines that are shown right here, line 1 and line 2. Now, and then we have two intersecting lines that have helped us form a triangle and some angles here. So as you can see, we've been given angles, this degree angle, which is 63, and this one, which is 61 degrees. So now we need to look at numbers 1 through 12 and find those angles as well. So how do we do that? Well, first, let's go ahead and get this triangle solved. So let's start by solving for angle 7. So this is going to equal 180 altogether, which is awesome. So now that we know that, we can add together 63 and 61 to get 124. And if we subtract 180 from 124, we get 56, which 7 is going to be 56 degrees. Now the cool thing about this is we notice that 1 and 7 look exactly the same because they are similar angles. So 7 is also going to be 56 degrees. So we can go around here and look at another similar angle, which is going to be 12, which is also going to be 56 degrees. So now once we figure those out, we're able to figure out most of the other angles as well. So number 2 is going to be 63 degrees, 3 is going to be 61 degrees, 4 is 61 degrees, 5 is 56, 6 is 119 degrees, 7 is 56 degrees, 8 is 124 degrees, 9 is 61 degrees, 10 is 119 degrees, 11 is 124 degrees, and 12 is 56 degrees. Now you're going to say those numbers sounded exactly the same. So let's look at those relationships between those. So we're going to just pull up the same exact shape, that same list I just showed, and after we look at that, we can see this cool table. So this is going to tell us what the similar angles are, complementary and supplementary. So what are those, you ask? Well, complementary angles, you will see we have none. That is because that means that two angles on here, or more than two, have added to equal 90. None of our angles did that, so we have no complementary angles. However, we have quite a few supplementary and similar, but let's start with similar. Similar angles mean that they are corresponding angles and are congruent and have corresponding sides that are proportionate. So let's look at 1 and 5 like we did before. Those were both 56 degrees. They're corresponding, they have the same proportion. 3 and 4, same thing. Because of this X right here on this vertices, it has cut them in exact slices, kind of like a pie. You hope that those pieces look exactly the same. That's how we can think of this. 6 and 10 have a similar relationship down here. 6 is 119, as is 10. 7 and 12, same thing. We have 56 degrees for both of those. 8 and 11, we have 124 for both of those. 2 and the angle that has 63 degrees, 2 is also 63 degrees. And 9 and the angle of 61, this little angle we'll call 61 degrees. Those are both 61 degrees. So supplementary, what is a supplementary angle? Well, that means that they add together to get 180. So we have quite a few of those here. 1, 2, and 3 all add together to get 180. 2, 3, and 5 all fall along this line, and those add together to get 180. 2, 1, and 4 all fall along this line right here and add together to get 180. 6 and 9 add together to get 180. 7 and 11, 7 and 8, 8 and 12, 9 and 10, and 11 and 12. So let's not forget about supplementary angles, similar angles, and complementary angles because we're going to need those moving into problem number 2. So here in problem number 2, we are given this lovely triangle, which has like a rhombus on the inside, or if you like to divide that up again, you can easily make 2 other smaller triangles. but I'm just going to call it a rhombus. So here's what we have to do. We need to find those missing angles. But what can we notice about this right now? Well, the larger triangle, A to B to C, you see that C is labeled as 74 degrees and B is labeled at 26 degrees. So that means A needs to add to these to make 180. So what can we get? 26 and 74 is 100. So that's going to make A 80 degrees. So let's move on to the second one. Now 1 and 5, what can you tell? They're the exact same size. So 5 is also going to be 80. So let's help ourselves out here. 3 is the same, similar to 1. So that is also going to be 80 degrees. Now let's use what we learned from question 1 and find angle 2. Well, actually angle 4, sorry. So the reason why we found that next is because 74 plus 80, to get 180, you add 26. So angle 4 is going to be 26. Now we're on to angle 2. So those are going to be our wonderful little lines that add together to equal 180. And that was our supplementary line. So we'll see those in our next chart. So keep going, and we're going to see that 2 and 7 are the exact same measurement. So that's going to be 100 degrees as well. And then angle 8 is 80 degrees. And angle Q is sorry, I said Q. Angle 6 is 74 degrees because 80 plus 26, you need that 74 to equal the 180. So let's take a look at those similar complementary and supplementary angles. So here we have similar angles, 4 and B. So here's B, and there is, let's see, there's our angle 4. Those, you see that this triangle looks just like that triangle. So you'll see that 3 and 8 are both 80 degrees, and that 4 and 24 and the 26 degrees, and 6 and point C as well. 1, 3, 5, and 8 are all similar. 2 and 7 as well. We again had no complementary angles because nothing added together to give us 90. Supplementary, we had 2 and 3, so right there, 180. 7 and 8, 180. 4, 5, and 6 add together to give us 180. 3, 4, and our point C here add together to give us 180. 6, 8, and B add together to give us 180. And 1, B, and C add together to give us 180. And that's what we did in the beginning of the video. So let's go ahead and move on to question number 3. So in this problem, it gives us a concave polygon, and we need to find the angle measurements. So here we have, you'll see some 3y, 7y, and 12y. So first, we need to use the formula n minus 2 multiplied by 180 degrees to give us to help give us the answer. It's just step 1. So n is going to be our number of sides that we need. So this particular case, we have a number of sides of 8. So we're going to have 8 minus 2 multiplied by 180, which is going to give us 6 multiplied by 180 equals 1080. Now, are we done with this problem? No, because we haven't solved the 7y angle measurement, the 3y, or the 12y. So let's go on and get into that next. So now that we have the 1080, we're going to get our shape pulled back up here, and then we're going to set the sum of the measurements of the interior angles equal to the value of the sum of the measures and solve for y. So what that means is we're going to take 3y plus 7y plus 7y plus 7y plus 3y plus 12y plus 3y plus 12y, and we're going to set that equal to the 1080. So once we have that, we have 54y equals 1080. We're going to divide the y, both sides, by 54 to get that y isolated for us. And we're going to find that y equals 20. Are we done? No, we're not done yet. So now we're going to plug in that 20 anywhere we see a y. So in the cases that we see 7y, that means 140 degrees because 7 times 20 is 140. Anytime we see that 12y, we're going to see that that is 240 because 12 multiplied by 20 is 240. And then 3y is going to be 60 degrees because 3 multiplied by 20 is 60. So that solves number 3. Super easy, super awesome. And for this problem, we have something similar, except we're going to find the interior angles, the exterior angles, and also the center angles. So let's go ahead and look at those formulas. So for interior angles, we need the formula of n minus 2 multiplied by 180 and then divided by n. For exterior, it's going to be 360 divided by n. And for central, it's going to be 360 divided by n. So what do we need first? We need our n. N equals 9 in this case. So I'm just going to go ahead and point out the interior angles are just that, the inside angles, these right here. The central angles is this. It looks like the piece of pizza. It's right there. And then the exterior angles are, if you draw a line on all these points, they would stick out. That is our exterior. Let's go ahead and do the hard one first. It's not really hard. It's awesome. Interior angle. So we have n minus 2. So that would be 9 minus 2 multiplied by 180 divided all by 9. That's going to give us 140. Our interior angle is 140 degrees. Exterior. The cool thing about this is for exterior, our same answer is going to be for central. So we have 360 divided by 9 is 40 degrees. Same for central. 360 divided by 9 is 40 degrees. We solved that super fast because we knew it all, you guys. Okay, so for number 5, let's take a look at it. We have a cube, and all the vertices are labeled, but you'll notice that the dotted purple line, those are the vertices of D, E, H, and G, and the rest are in this lovely mint color. So let's take a look. So this problem wants us to draw a tetrahedron inscribed in the cube that has none of its faces in the planes of the faces of the cube. So what does that look like? Let me show you. So here we've only labeled our vertices of D, E, H, and G. That lovely red line right here, this whole thing is our tetrahedron. Now a tetrahedron, it has 4 equilateral triangles in it. So 3 sides and a base, and they're all equilateral. So here we're going to show the 3D element. So we've drawn 3 solid lines, one from D and E, one from E to G, and one from D to G, and then some dotted lines from E to H, D to H, and H to G to help form our tetrahedron. And that is what we have done. So let's go ahead and move on to number 6, which is going to give us another look at these. So let's take a look at tetrahedrons, octahedrons, and icosahedrons. So a tetrahedron, as I said before, has 4 equilateral triangles. You'll see we have the 3 sides and a base. An octahedron is if you took 2 tetrahedrons and kind of fused them together because it has 8 equilateral triangles. Now, the amazing thing is an icosahedron, that actually holds 20 equilateral triangles. That's a lot. I've drawn them all here. If we were to rotate this, it would look exactly the same. So that is what we have for Chapter 9. I hope you all enjoyed watching me, and I will see you guys next time. Bye.